Lategahn and I'm the managing director of the company called Atlatec. Most of the systems of self-driving cars that I was able to get to know are heavily based on high-fidelity maps. So usually the approach is so that a lot of the spatial information that doesn't change over time. So static information that is non-dynamic and change persistence over quite a period of time can be placed in very accurate map data structures. And then, once a car is driving without a driver, then this information can be used to navigate the car. So if the lane boundaries are already known, then these don't have to be detected online during self-driving operations. The final decision of what information needs to be contained in these map data structures for self-driving cars are not completely answered yet. I think time will tell. I think that Google and also here is really doing a good job in placing this information in the map data structures. They have noticed that there's a great need for this kind of information in their map data structures. So the approach that here in Google are pursuing is that they equip their mapping vehicles with very expensive sensors. So they use laser scanners and they use very highly accurate GPS receivers. And then they survey the area for which they want to create the map, acquire the entire data set, and then enhance the data structure by whatever information is required. So there could be lane boundaries, could be stop lines, could be curb stones, and a lot of more information. One big challenge that remains unsolved so far is that once the level of detail in these maps increases, as they do right now, then the validity of these maps decrease over time. So these maps need to be recomputed, remapped quite frequently, and the more details there are inside that map, the more frequent remapping is required. And to date, I don't know of an approach which would be feasible to keep these map data structures up to date, which doesn't cost too much. So using a very advanced and highly equipped mapping vehicle and then sending a team of engineers to remap everything on an annual basis or even more frequent, I think will not be feasible and possible to do in the future. One of the problems that need to be solved first is how to detect that there has been a change inside that map, so that then a mapping vehicle can go to that area and then do the remapping. So that's also an issue that needs to be solved. Right now, specialized companies do the mapping and use these advanced mapping technologies and these very expensive sensors that are out in the field right now. We at Atlatec also developed a system which can be used to create high-fidelity maps. We created a sensor box which is really small and handy and weighs only a few kilos, and it contains mostly cameras, so it's based on stereo vision and computer vision in general. And that box can be used to create 3D maps of the area that has been surveyed. And these 3D maps are computed completely automatically. And these 3D maps are very dense, and that allows us to generate top view rendered images of the road surface from these very dense 3D maps. And one of the major differences between the mapping device that we developed and here at Google is that we don't rely on very expensive sensors. So everything fits into a box which is the size of just 30 centimeters by 30 centimeters, and it's portable and it runs on batteries, and it's really handy to operate. And the sensors that are used inside that box could potentially also be used in the mass market production in serious cars. As mentioned earlier, one can free one from a lot of problems by placing spatial information in the map data structure for self-driving cars. But this information that is contained then in the 3D map can only be used and can only be of value once you know where you are inside that map with very great precision. So if you have a localization accuracy of 30 centimeters, then all the objects that are placed inside your map data can only be retrieved relative to your car by the same accuracy. So the greater the accuracy localization-wise is, the greater is the use of these objects that you place inside that map. So a highly detailed map cannot be used if there's not a localization solution available which is of the same accuracy of the objects that you have placed inside that map. And here at Atlatec we are following an approach which is not based on satellite navigation but rather on computer vision. So once these 3D visual maps have been computed, the system can be used online in the car to compute the position of the sensors and the box and the vehicle relative to that map. And we do that entirely from the images of the cameras. So it's not based on satellite navigation. There's always the opportunity and the possibility to record GPS information during map acquisition. So if this information during mapping is available, then the entire 3D map that we can create is also georeferenced. And the accuracy of the global reference then entirely depends on GPS receiver. But then once again, for many applications with respect to self-driving cars, the global accuracy is irrelevant. Everything that matters is how accurate can one position the vehicle relative to that map. And that really plays into our hands because we focus entirely on this map relative localization accuracy, which we can achieve by computer vision. In many areas, I believe that is true, yes. So high precision GPS is not required for self-driving cars if there exists a method which allows to localize relative to a map structure. So computing power is simply required to achieve the accuracy and the resolution that we can achieve with our approach. And speaking of computing time, so right now our system roughly requires 4 times the time it took to drive to compute the maps. But that is also a very, that's current research, and that is one of the things that we very heavily work on, and of course we are trying to reduce that time. But that's basically the time that we need right now. Right now we are very heavily focusing on the automotive industry here in Germany. We have plenty of companies in Germany which we are happy to be able to work with. To name a few of the known companies is Volkswagen, it's Audi, it's BMW, and a few more tier 1s and tier 2s. And there are 2 application areas and 2 use cases that our customers use this technology for. So one is self-driving cars. Once a map can be created easily with very high precision and with all the spatial information that you need for self-driving, and at the same time you will get a device which allows you to localize relative to that map, then you can really, apply that technology to self-driving prototypes. So it's only a handful of cars that use that technology. That's one. So self-driving cars, and also jump-starting projects for companies that want to get started in this business. It's really a nice getting started using our system. That's one. And second is that the combination of high accuracy 3D maps on the one hand and map relative localization can also be used for validating and testing advanced driver assistance systems. The problem right now is that many systems that reach the market in the near future need to be tested before they reach the final customers. And to evaluate these driver assistance systems, the OEMs and tier ones are depending on reference data that they can compare the output of their system to, and then to get massive amounts of reference data to get a feeling for the accuracy and the reliability of their systems. And 3D maps and map relative localization are a good starting point, and our system enables the customers to generate these reference data by themselves. So we don't provide that as a service, but we enable our customers to do that themselves. We provide the hardware that is required to record the data on the one hand, but we also provide the software which translates this massive amounts of recordings and data into these 3D maps and these reference data. So once our customers get their hands on the software and the hardware, they are free to start and operate the system completely independently of us. We are also interested in starting business in other business areas. One thing that we are currently very actively pursuing is to find project partners to apply this 3D mapping technologies to, for instance, road inspection. That seems to be quite a big topic, especially since the sensors that are used in our system are rather low cost, and we would be easily able to provide the entire setup to the offices of the cities that are in charge of road inspection. So that's another thing that we're looking at. Maybe one of the largest challenges which seem to be unsolved, in my opinion, when it comes to self-driving cars, especially in combination with highly detailed maps, is how to keep these maps up to date without paying too much money. How can this be profitable? I don't quite see a solution out there. Using low-cost sensors like cameras, which are used in many cars, could be a way to go. So I think that's one of the greatest unsolved challenges so far. Well, apart from these technical issues, I think legal issues are still top on the list for self-driving cars.